First, you have to decide whether the trig part is the inner function or the outer function. Okay. And this is typically by putting in parentheses where you need it. Okay. Sometimes they will have parentheses, but if you remember trig from last year in pre-calc, sometimes we put the squared kind of in a weird spot with the sine squared, cosine squared functions. So by changing how a trig function is written sometimes, it tells you what is the inner function and what is the outer function. So a lot of trig, it's not that the chain rule is any different, it's just learning to think about whether the sine or the cosine is the inside function or the outside function. So for example, 1a here, where is the only place I could put parentheses in 1a? What are we taking the sine of? 2x. So the only place that I could put parentheses are right there. What that tells me is the sine is the outside function, and what's the inside function? The 2x. So when I go to use the chain rule on this, the chain rule says take the derivative of the outside function. So what's the outside function for this one? The outside function is the sine, right? So what's the derivative of the outside function? Cosine. You keep what's in the parentheses the same, and then you multiply by the derivative of the inside function. What's the inside function? 2x, so the derivative is 2. Now, I saw this on some of your product rule, quotient rule quizzes. That 2 does not get multiplied by the 2x. Okay? That 2x is already in parentheses. It's locked there by itself. Where's the only place I could put that 2? In front of the cosine. Any issues or questions as to where that comes from? All right, so B is even kind of simpler because there's already parentheses there. What's the outside function? Cosine, right? So we first take the derivative of the outside function. What's the derivative of cosine? Negative sine. Keep what's inside the parentheses and then multiply by what? The derivative of the inside function, which in this case is just what? 1. Which doesn't change anything in this case, but you just have to be careful. Okay. Any issues so far? All right, now we might have to look back in our notes for this one because the outer function is tangent. This is not one that I've told you that you need to memorize right now for our sine, cosine, tangent derivatives. So the derivative of tangent is, I don't even memorize these. That's always good for me. Secant squared. Yeah? All right, so where could I put the parentheses in C? The 3x, yes? All right, so when I work through C, I've got parentheses in C around the 3x. So first we take the derivative of the outside function, and as we just said, the derivative of tangent is secant squared of that 3x. How else can you write secant squared, just for reference? What is actually being squared? The whole thing. So if you don't like that secant squared like that, it's really that. When we write secant squared, it really means the whole thing squared. Okay? Then you multiply by the derivative of the inside function. Okay? The derivative of the inside function is just what? 3. So you can write it as secant squared if you want. If that doesn't confuse you, you can write it as the entire secant all squared. That's okay, as long as you use parentheses. All right. take a minute and try 2a. Given that there are no parentheses, where's the only place you can put them? Around the 3x squared. All right, so take a minute, try that derivative. Yeah, I'm going to skip b. You won't see much like that. How is c different than a?
Squared on the outside.
Okay, what is that squared squaring right now?
The 3x.
The 3x. How do I know that is not squaring the whole thing? There's not parentheses. So the only place that I can put parentheses is that. Okay, it's squaring the 3x. It is not squaring the cosine. If it was squaring the cosine, they would have to have parentheses like this. Okay? So what that means is the inner function is this. This may be one that would just be helpful to simplify real quick before we do the derivative. When you square the 3x, what do you get? 9x squared. So it may be easier to think about it that way and then take the derivative just like we did in a. The outer function is the cosine. So the derivative of the cosine is negative sine of the inner stuff multiplied by the derivative of the inside, which would be what? 18x. The only place I can put that 18x is where? In the front. Okay. Now, all the ones we've done so far, the sine or the cosine has been the outer function. Let's look at a couple where they're the inner function, just to make sure that we know how to do those as well. So that would be like D and E over here. So D is where I say it's easier to rewrite it before you actually do it, because what does it mean? We just talked about cosine squared x. What does that really mean? What are we squaring? The whole thing. So it may be much easier, and not maybe. In fact, this one, if you don't write it this way first, you're probably going to get it wrong.
I feel like I messed up on the that stuff. You probably did.
If you feel like that, Zach, then you probably did.
All right, so what is the outer function on this one?
On which one?
On D.
X.
It's the squared, right?
Oh, yeah.
How do you take the derivative of something squared?
You bring it to the front.
You bring the 2 to the front, keep the inside stuff, and subtract 1 from the exponent. Then multiply by the derivative of the inside. What's the derivative of the inside? Negative sine. Okay. All I might do with this one is simplify the 2 and the negative to make that negative 2 cosine x sine x. Okay, well that's just numbers. This is just a 2. This is just a negative 1. I just multiplied those together and put that number in front. Multiplied by a cosine and a sine. All right, what's the outer function on E? What's the outer function on E? The square root. How have we learned to write square roots so that we can take derivatives? All right, so before we ever do the derivative, we write it as cosine x to the 1/2 power. How do we take the derivative of something to the 1/2 power? Bring the 1/2 down front, subtract 1, and then because this is chain rule, multiply by the derivative of the inside, which is negative sine x. All right, real quick on this one, simplifying. There is this all raised to the negative 1/2 power. Where does that mean it's going to go in my answer? The bottom. Guys, shh. Therefore, what else is going to go on the bottom?
The what?
What else is going to go on the bottom?
Nothing. The 1/2.
The 2 from the 1/2.
That makes sense.
What else is going to go on the top?
Negative sign.
The negative sine x. The negative multiplies by the 1. And then I get sine x.
Not too bad.
No?
Not too bad.
All right. This one is interesting because there's 2 different terms. Remember that when we did derivatives initially, if there is a plus sign, I do the 2 derivatives separately. Is the derivative of 2 sine of x complicated to find? No. What is the derivative of 2 sine of x? 2 cosine of x, right? You just keep the constant and take the derivative of sine. That doesn't require a product rule, quotient rule, chain rule, nothing. That's just a normal trig derivative. That's that first term. Let's look at the second one. This one does require something special. What's the outer function? The outer function is the cosine. The inner function is the 2x. So I took the derivative of the first term normally. The second term I have to use chain rule. So chain rule says derivative of cosine is what? Negative sine. Keep the inside stuff and multiply by the derivative of the inside, which is just what? 2.
Wait, will we need to do the chain rule like on our quiz?
No, you did not. All right, so once you find the derivative, how do you find the slope?
30-minute.
How do you find the slope? Plug in your x. Let's just say that we forget how to plug in pi. Well, don't use 3.14.
What? That's what I did.
Well, you could, I guess.
That's what we did on the quiz.
You could use the pi button in your calculator.
True.
All right, so take a minute in your calculator. That we do on this is your y minus y1 equals m times x minus x1. If I distribute, it gives me negative 2x plus 2 pi. And then I just add the 1 to the other side because I can't really add it to 2 pi. All right. We only have about 5 minutes. I'm not sure we need to do more of these.